All right, example 4 says, show that the derivative of cotangent inverse is equal to -1 over 1 plus x squared. Okay, so it's saying show, so it's saying prove it. Show me that you know how to get to that answer. So the first thing I do is I'm going to use the the ideas that I've just used in my previous right triangle trig review video to rewrite this. Okay, so it's not an inverse. So typically this is your function y, so I'm going to say y equals cotangent inverse of x. Now I don't know off the top of my head, actually we do because it's written right here, but let's just say we don't, the cotangent inverse. So what I'm going to do is get rid of the inverse and move it to functions that I know. Okay, I know that I can take and get rid of cotangent inverse by taking cotangent on both sides. Okay, so I have cotangent of y equals x. Now what I'm going to do here is I am going to take the derivative of it, because that's what this is telling me to do. Okay, so I'm going to take the derivative, and since I have y's and x's mixed together, I'm going to do it using implicit differentiation. Okay, so take derivative using implicit. All right, so derivative of cotangent of y. The derivative of cotangent of y is negative cosecant squared of y. And then I took a derivative of a y, so don't forget you must write dy dx is equal to the derivative of x, which is just 1. Now what we must do is get dy dx by itself. So the way we do that is we divide both sides by negative cosecant squared of y. So I'm getting a little bit closer. I have this -1 over cosecant squared of y. I'm going to just do a little bit of simplifying. Cosecant, we all know, is 1 over sine. So I would have dy dx is -1 over sine squared, my bad. So when I have a fraction within a fraction, I can flip and multiply. So my derivative dy dx is really equal to negative sine squared of y. Good, that looks great. However, that is not what this is saying to show it equals to. Okay, so in order to get it in terms of x, I'm going to go back, like our example 3 that we just did, and I'm going to set up a triangle. Okay, I'm going to set up a right triangle, and I'm going to find all the sides. Then I can find the sine value. Okay. So I've taken my derivative and I'm trying to get to this point. So going to my cotangent. Cotangent of y is equal to x over 1. Okay. Cotangent is the reciprocal of tangent. So if we think about tangent, that's our TOA. Tangent's opposite over adjacent. So what this would tell me is you flip this is our adjacent of our triangle, and then this is our opposite. So I'm going to set up that triangle. It's for angle y, and so my adjacent is x and my opposite is 1. In this case, I don't have my hypotenuse, so I'm going to solve for my hypotenuse. Okay, so hypotenuse usually we do c, so c squared is equal to x squared plus 1 squared. And then to get c by itself, we take the square root, so it'd be x squared, and then 1 squared is 1. So my hypotenuse in this case is the square root of x squared plus 1. Now I can use this triangle to find sine of y and then square it. Okay, so I'm going to do a little substitution. So I got my dy dx is equal to, I got negative. Now sine is opposite over hypotenuse. So y, my opposite, is 1. Over my hypotenuse, square root of x squared plus 1. And then this is not just sine, it's sine squared, so I would square both sides. Sorry, no, I would square it. And then I'm going to simplify dy dx. The negative stays. I would say, well, 1 squared is 1. All over the square root of x squared plus 1 squared would just give me x squared plus 1. And now, do they equal what I was to prove or show? Yes, it does. Okay, so there is example 4.